All right, so my name is Telmo Santos. I'm a software architect, and today I'll be telling you about the Do Automation Observability Stack. It's a continuation from the presentation that Amr gave about the Do Automation project, and I'll be focusing on monitoring, log aggregation, and insights extracted from those logging and monitoring data through GenAI LLMs. So here the agenda. I have just a couple of slides for introduction. Then there are 4 sections, one section for each one of the observability components that we have onboarded already. And then at the end, I'll wrap up the presentation with a summary and some key takeaways. So starting with the introduction, just a few words here about the high-level architecture of the Do Automation project. You probably got the idea from Amr that this project is a large-scale project. And on this slide, I'll try to show you that this project has complexity at many levels. One of the levels of complexity is at the amount of use cases. There are more than 50 use cases in the project. Then regarding the automation components, we have one NSO, but it's not just one. We have 2 NSOs. We have a second NSO for the data center track. Towards the northbound, we have Cisco SPIS as the main automation portal, and we are also using Cisco BPA for the workflow capabilities. So we have some complexity here, and I'm not even adding the Ascedian integration that will come very soon now as well. Regarding infrastructure and deployment, NSO it's a single server deployment. SPS and BPA are Kubernetes deployments. So we have a Kubernetes cluster, we have a database cluster. And so that means that there are many VMs on each one of these components. And then we multiply all that by 2 because we have GOAJ in our solution. So complexity at the infrastructure level as well. Regarding external integrations, I'm just listing some of them here, but there are many of them. And we need to ensure always that they are available, that these services, that we can connect to these services and everything is okay. Towards the northbound, we have many operations and planning teams that access the portal to configure and trigger the use cases. But we have some programmatic accesses to our automation cluster as well through other orchestrators. And then, of course, towards the southbound, we have the complexity on the network. So I just spoke about all of these different levels of complexity. And this is really one of the most important whys of observability. We have so much complexity. How do we ensure that all of these components are active and are reachable and they are talking to each other as they should? So that's why we need observability. And what are we exactly looking for in observability? We want to have real-time visibility of what is happening. We want to avoid problems if we can with proactive maintenance. If we cannot avoid them, we want to troubleshoot them fast. And then we also want to ensure that we have a good resource utilization in the automation cluster. And so then we enter our observability journey. And this is a representation timeline of what happened throughout the years. And you will see the different components that we added and how they return value to us in terms of observability. So we started with a really small component called reachability monitoring. This is something that is just checking periodically if different services are active or not, reachable or not. Then we added Prometheus server and NSO monitoring. After that, log aggregation with Loki. And then with all that data, we started to think of the best way to extract insights from it. And now we have an ongoing POC, of which I'll show you some results, some interesting results, using GenAI to extract those insights. And towards the future, we are planning to onboard OpenTelemetry with Jaeger. And this relates with the observability exporter module from NSO, and also relates with the presentation gave by Roque Galliano on Tuesday regarding OpenTelemetry as well. So this follows the chronology here of the presentation. I'll be talking about these 4 main components. For each one of the components, I'll follow the same sequence. I'll tell you why we decided to use it. I'll tell you about the high-level architecture. I'll give you details about the configuration and some of the features that it has. And I will wrap up each one of the components with a true story from production so that you understand where we extract value from it, and hopefully you will see value on it for your cases as well. At the end, and before just moving to the next slide, I would like to keep in mind that for us, in this journey, we always had to make a decision on what would be the best choice to maximize our observability value and reduce the amount of effort or risk that we need to put into it. And I think both case of Prometheus and Loki, on those cases, we really hit the nail on the head, because we didn't use any coding, it was just configuration, and we didn't add any compute resource. We just used what we added. So small investment and big output of value. So let's talk about the first component, reachability monitoring. Why we need it? Well, we just spoke about the complexity in the cluster. We learned the hard way. We learned that sometimes a single component can cause a large disruption on our network automation cluster, and we needed to be notified if something happens. We didn't have that from the beginning. So the first I want to tell you about the high-level architecture of the solution. Again, as I said, fairly simple. If we want to monitor something, we give a curl command, and then we just say which one is the HTTPS code that we expect, and some keyword that we are expecting also to see from the output of that curl command. So once that is configured, the system goes, and every few minutes, it goes and pings and checks the reachability to the different targets. And the result of that is stored on our database in Postgres, and we have some dashboards to show that over time. Additionally, we also have a type of event-driven notification where we detect the cases of when a system or a service has become reachable from unreachable, or the opposite, and we notify a distribution list with that. Very quickly here on the configuration, this is the UI that we have. It's simple. You give it a name, define the curl command, the code, and the payload that we are expecting to see. If we have a match, it's reachable. If we don't, it's unreachable. And then once we have the data, we can open the dashboard and see the reachability status of all these different systems. Of course, if it's green, it's reachable. If it's red, it's not reachable. And then there are some emails that are sent when there are changes, as you can see down there. So those notifications are just represented here. This is an example of an email that I sent with this event-driven logic behind it. Finally, regarding reachability monitoring, I want to tell you a real story. This is from our production systems. In one occasion, we were seeing degradation in actually some of the use cases. We came to the dashboard, we opened it like this, and we saw that at a specific moment in time, we had 5 different services outside of our automation cluster that started to have this intermittent outage at the same time. So then this quickly allowed us to understand that the problem was not from the automation solution. We shared this with the customer, and then it was found from the infrastructure side that this had been due to a data center network misconfiguration. But the idea here of the value, towards the value, is that the time that it took from us to identify the issue, to actually understand that in this case it was not related with our automation, was very fast. So this is where value is coming from. Now let's go with a second component, the Prometheus service and NSO monitoring. Why we need it? Well, we also understood that the server performance is changing over time. We had some cases, and I will give you an example of that, where the VM resources were actually reaching their maximums. And we wanted to have a way to track the usage of different NSO packages. So the high-level architecture here is based on a configuration of Prometheus. In the next slide, I'll show you this configuration file. But it's quite simple. You just tell Prometheus which ones are the servers and the ports of which exporter processes Prometheus should scrape every, let's say, 1 minute. So this is just a representation of a Kubernetes server, representation of an NSO server. For the Kubernetes server, we have statistics for the server itself, statistics for the processes, and specific statistics for Kubernetes. Something similar here for NSO. But we have these 2 exporters, these 2 processes that are listening on a specific port, that are collecting statistics, in this case, specific of NSO packages. And these are internal metrics of NSO. This one is only available on NSO 6. And by the way, these two components, they were presented last year on this conference on that day. So we saw the presentation. We had access to GitHub, and then we just adapted that and we integrated that into our solution. So once these statistics are collected, Prometheus is storing them on PromQL, and we also have dashboards to visualize them. Just a few insights here on the configuration. It's quite straightforward. From the top of the configuration file, you can see you can define the scrape interval to say how often you want to make the scraping, and then you just need to say what is the IP and port of this exporter, and then the exporter will get the request, will collect the statistics, and send it back to Prometheus, and then just store it on the database. So again, no code needed. You just need to configure these targets. Once it's configured, Prometheus allows you to see the status of each one of these targets or these components that are being monitored. You can see the state in green. If it's up, it will tell you that if something is down, or it's either connection refused, or sometimes can be timeout. And you can even see the scrape duration in case you're worried that this monitoring process might be taking too long, or itself is consuming too many resources. You can see here how long it takes to scrape the data. So now that we have all the data, we can visualize it. So from the top there, top left corner, we have the node exporter with the statistics of the CPU, process exporter. So these are process operative system specific statistics, process statistics. And these two down here are the ones related with NSO. So we can see the usage of different NSO packages over time, and metrics of NSO as well. Has the session and commit queue, etc. So for this component, we also have some real stories. So in this case, we had identified that one of our servers had 100% CPU utilization. We came to the dashboard, we adjusted the timeline, and we saw that actually the CPU utilization had been increasing progressively in the last weeks. So it was not something that was just momentaneous, that was in that moment. And actually, this was then identified to be caused by a third-party agent installed by the infrastructure team. And you can see here the moment when it was restarted, and then it started to do the same thing again. And after this, it was agreed to just disconnect and to disable this agent in one of our servers. But again, the idea here is that this type of visualization allowed us to interpret the behavior of this agent. And it gave us more confidence to know what we needed to do. And we could also track what it was trying to do again. Okay, and it has a second real story. I want to show you here the visualization of utilization of different NSO packages over time. We have 50 different use cases in Do, but actually these 50 use cases, they map to more than 70 packages in NSO. So there's a lot of stuff that can be used. And we can see over time, you can see some periodicities here. And we had a specific case where a specific NSO package should be called every 5 minutes. By looking at the chart, we identified that we had these peaks every 10 minutes. And so we identified from this information that we had a misconfiguration on the process that was calling it. So we corrected it. It was moved to 5 minutes. And then so we fixed this problem based on these insights. And for me, as the product owner of some of these use cases, I need to have access to this information. I cannot just put a use case in production and forget about it. I need to be sure that that is being used. I also need to know how frequently it's being used, what is the resource consumption or the impact, for example, in NSO. And I also need to know who is using it. And later on in the presentation, I'll try to show you how we try to extract all this information automatically using the LLMs. All right, moving to log aggregation. Why did we need it? Well, we wanted to have a solution where we have persistent log storage. We also have a large number of log files. They're all with different formats. We are not, in many of our components, we are not really following specific log format. And then we have a difficulty tracking logs from one system to the other. You saw SPIS, NSO, BPA. It's difficult to track what's happening from one to the other. So in terms of high-level architecture, contrary to Prometheus, here is the opposite. We have is not a listening agent on the target system. It's actually it's not a listening process. It's actually an active agent, prompt-tail agent, that is monitoring the specific log files. And if nothing is happening to the log files, there's nothing that is sent back to the server. But if those log files are updated, if there's new lines of text there, then the prompt-tail agent automatically sends it to Loki, and then Loki is storing it on the LogQL database, and we also have dashboards to see that all that data integrated. So next I will show you some quick configurations here of the prompt-tail YAML file. So also quite simple here. We just need to say where are the files that we want to scrape or to monitor, and that you can use regular expressions to get access to identify multiple logs, and we tell it where to push the data. So this is where the Loki server is listening and waiting for this log messages. Then once we have all this data, we can see the log messages being or changing, or the amount of text on the log messages changing over time. And we have a single plane where we see messages from different logs. And there's even some basic identification and tagging that log is doing, identifying errors and putting them in red, or info to be green. So it gives us this type of visibility. In terms of the real story here for the Loki log aggregation, I would like to tell you about this specific error that we were seeing in our front end. It was a 400 client error. It was not very descriptive. It was just saying, okay, we get this error towards that API. And what we did was we went to Loki. We searched for that error message. We found the error message down here. And then Loki allows us to see all the previous messages from all the different logs, even from different systems, because it's centralizing all this log collection. And this was very valuable to us. So we can see here from the top that the portal where this error was happening was, it was saying that it's triggering this call to NSO. Then we see the NSO audit log confirming that there is an external access to this action. We have the package log in NSO with the different messages, and we can see down here the reason for the problem. Device is logged in the sync from operation. So it allowed us to quickly see all of this without having to go to the servers and search in the logs and match timestamps, etc. Now, at this point, it's important to remember that Roque Galliano, in his presentation, he told us about using OpenTelemetry and how by using OpenTelemetry, there are some IDs that you can use to track a request from one system to the other. And then he showed that, some graph of that with the Jager, what was quite nice connection and interpretation of the request. So here we don't have that, right? We don't have that, but Loki allowed us to have this complete view organized by timestamps. And part of the beauty of this, at least, is that we did no change of code in SPIS. There's no specific rule on the log message that we are using. Actually, some of this code has many years, and we prefer if we don't need to change anything. So even though maybe we don't have the full capability of OpenTelemetry, which we want to go into that direction, this was something that really required small effort, and this gives us a lot of value to integrate and to see all these logs together. All right, so we spoke about the data of monitoring and the need to, as a product owner, to be able to understand what is the usage of the packages that relate with my use case, and also this data that we have and that we can use for the logs. So then we started to think how we can extract this insights in a better, more automated way. So we wanted to have automated way to extract the insights. And for me, I think it's quite important to be able to have this human-like interaction to analyze data and insights. Because of course we can have some threshold crossing alerts, but often the interpretation of how a use case, for example, should behave in production, maybe only that I'm the product owner knows about it. And maybe I want to ask different questions, I want to go deeper into something. So this interaction, the human-like interaction, it's important. So we started to work on this use case. It's a POC. I don't have a demo to show you, but there are some details here of the architecture and most of the tests that we've done with Bridge IT, which is the enterprise version of ChatGPT 4 that we have available in Cisco. And this architecture is not very different than what you've seen in the previous sessions on this conference. So we have a user connecting to a WebEx bot, and then on our backend we have this, we can call it observability agent with retrieval augmented generation capabilities. So the agent will interpret the question that comes from the user and will take into account the data that it has available in terms of even charts, Prometheus data, monitoring data, or Loki. And then it will build a prompt down to the LLM service to request this insight. And then we can have this conversation between the user and the LLM through the observability agent. So again, as I said, we don't have like a demo here to show you, but I would like to show you some results that we found to be quite interesting on the capabilities that these LLMs have. So starting with this data, again, this is data of NSO package utilization over time. You see different colors for different packages. You see there the NSO, the NCS process, and then other packages here. And you might identify visually that there's some periodicity on the blue line and on the red line. You might even identify that the red line over time seems to have kind of an onset, is kind of growing a bit. And we wanted to identify if the current state-of-the-art LLMs, the ones that we have available, if they're able to detect and to provide insights on this or not. So the prompt that we created, from the prompt that we created, we get such an output. So regarding periodicity, and we're just giving it a bunch of numbers. It's basically just a big table with timestamps and numbers. And we are asking the LLM, do you find periodicities here on the data that we see here? And it does so. So there appears to be a periodic pattern in the utilization of the NCS and BGP transit peering optimization with intervals that could be around 5 minutes. So this is exactly correct. This is exactly what we see here. And we also ask it to try to see if there are trends. And it says, regarding trends, unlike the NCS, which is the blue line, the utilization seems to be increasing with each cycle indicating an upward trend, which is exactly a very good interpretation of what is happening here. So this for us, it tells us that Bridge IT, or the enterprise version of Cisco of ChatGPT 4, has good data analytics capabilities. And this was something that was not evident to us. I mean, we know that they are good at text, but if they are good at interpreting data like this, just interpreting numbers, that was not clear to us. So it was a good insight for us on this. Then we also wanted to know the other type of data that we have on observability is these logs. Can it interpret logs? Is it capable to interpret logs or not? So the prompt that we had in this case was, we were just providing some the audit log from NSO. We were not explaining anything about the format of what exactly is on the log. And we were just asking, can you please tell me which one is the user that is mostly using the specific package? So I see some kind of weird behavior on a package, I can ask, who is the user that is using it? And maybe I don't want to go to the audit log. I want this to come directly to me through WebEx. And the output was, as you can see here, based on the log messages provided, it appeared that the user with a username BGP admin is the one accessing BGP transit peering optimization package using REST-conf APIs. So this is exactly correct. And again, this is was a proof to us that Bridge IT is good at the log analysis as well. So at this point, it's also important to remember, and you probably heard this multiple times in the sessions from this conference, that there are some limitations here. The outputs from the LLM, they are not always the same. And they're not always the same because by default, the temperature parameter that measures the randomness or creativity of the model, it's not set to 0. So we want, once we get programmatic access to this service, and we are expecting to get it very soon, we want to be able to do these tests with 0 temperature, means 100% deterministic. and to see what is the performance of that. And we also have limitations in terms of the context size. We are still working here with 8,000 tokens. So if we have access to more, we will be able to provide bigger log messages and bigger data as well. So bigger time range of data to be analyzed. So we have these limitations, but Sam Altman, CEO of OpenAI, just 4 weeks ago, said that ChatGPT-4 is the dumbest model that any of you will ever have to use again. So this gives us a good hope that what's coming next will probably come soon and will come much better. And already last week we had the announcement of ChatGPT 4.0, and there were some demos on the capabilities of data analytics. So we expect to leverage that and to integrate that here into our solution to extract value from it. All right, so we are reaching the end. So summary and key takeaways. For us in Do Automation, it was very important. The investment in monitoring and observability really enabled proactive maintenance and fast troubleshooting. So a lot of value extracted here from us, for us. Also very important to remember that adopting Prometheus for monitoring and Loki for log aggregation required a small effort and a large delivered value. It was a simple solution. There was no coding, no new servers. It was just configuration. We deployed this open source services, and they were just working and delivering value to us. And we want that. Regarding Bridge IT, we understood that it has good capabilities of both data and log analysis, and we are expecting future LLM versions to be even better, and we want to use that. And finally, just to remind you again that we see this observability has a journey, and we're just starting it. So thank you, and let me know if you have any questions.
Hi, Telmo. I know most of the topics, of course, but I have a question that just came to my mind. Do you think that LLM can expect or forecast what could happen in the future? I mean, if we ask him about what is the possible trends or what could happen based on this information, do you think that this is doable?
Good point. Actually, when I was doing some of the tests, and when I was looking here at the red line, I tried to understand. I tried to ask the question if we could predict since it can detect periodicity and trends. I was asking further questions. Can you tell me what's going to happen next, right? So this forecast capability, I tried to test it. It was not successful. I did not get the result that I wanted, or it was not telling me that it will grow. It will pass 300 after 3 weeks or something like this, or after an hour or so. But I would also say that in this process of prompt engineering that I was testing, in many situations, I was getting negative responses, sometimes even the LLM telling me specifically that, I'm not a data analysis tool. You cannot give me a CSV file. You need to do some Python scripting to do that analysis. But then you ask it in a different way, and it actually reveals that it has those capabilities. So I think there's still potential for that, and maybe on the new systems with 4.0, for example, it will be able to do that better. Yeah, so we are hoping for that too. Yeah. Thank you.